Okay, Coronius 100 integrals, number 33. This is it's actually a pretty interesting question. It's 1 over, you need to integrate 1 over cosine square x on 2 minus sine square x on 2. But if you just pay attention to the denominator here, that is just a double integral formula for the cosine, right? So therefore we know that cosine square x on 2 minus sine square x on 2 is just equal to cosine double angle, so 2 times by x on 2, which gives you cosine x. So that's actually a cosine x. So now, if we know this information, we should be able to integrate this one without any problem. So that gives us 1 over cosine x dx. And we know the reciprocal of cosine x is sec x, so that gives you sec x dx. Now, to integrate sec x, we need to use something that's a very special way of doing this before, all right? So the trick is we need to multiply both the top and the bottom by sec x plus tangent x. So this is what we do, sec x, we need to multiply both the top and the bottom by this term. Okay, there's a reason for it, which I will show you in a minute. So if you times both the top and the bottom of that by sec x plus tangent x, basically you haven't done anything, right? You haven't changed the question, so you're allowed to do it. Now, if we expand the numerator, we get a sec square x plus sec x tangent x. Okay? The denominator is equal to sec x plus tangent x. So here's the trick. Just by doing that, all right? And then if you differentiate the denominator so that the derivative of 10x is equal to sec square x, which you have it on the numerator. And if you differentiate the sec x, it is equal to sec x tangent x. You already have it as well on the numerator. So you've got everything. So basically what happened now is the derivative of the denominator, so, for example, the denominator is fx, and the derivative of the denominator is equal to the numerator. And that's one of the formula we use, which is in terms of logarithm. It's ln fx, absolute value of fx plus c. So that's the formula. So by using this formula, the answer to this question will be ln absolute value sec x plus tangent x plus c. So this is a really interesting question, and you need to remember that trick when you start to integrate sec x. You multiply both the top and the bottom by sec x plus tangent x. And after you expand it, you will have everything you need. So therefore, the derivative of the denominator is equal to the numerator, and therefore you can just apply the formula. Okay, that's how you do this question here. So of course, you do need to know this is a double angle formula for the cosine before you can work out the final answers there. Okay, thanks for watching.